Okay, here we go. First of all, I have given you a list here that I would want to look over right before I took the test. So like tonight, when you're studying, make yourself this list right now. These are good strategies you need to know. Excuse me. Talk about that later. Write these down in your notes right now. I will explain them briefly while you are writing them down. Combining fractions with a common denominator. Again, anytime you have two things and they want it to equal one, like to simplify it, or because it's a proof and there's two parts and all of a sudden there are one part in the answer, well, you need to be able to add things that have don't have common denominators. Like if I had cosine plus sine, I should be able to add them together somehow. Let's go with something more like tangent plus cosine. Because then it's a little more clear that one of them has a denominator right now. How could tangent have a denominator? Well, I could rewrite it as sine over cosine. And then it'd be sine over cosine plus cosine. And then to get a common denominator, I'd have to multiply the one on the right by cosine over cosine. And then they'd have a common denominator. All right. I don't want to go through that whole process because if you don't know how to do that by now, you've been not paying attention too long and it's too late.
Any order?
Okay, next one. What?
These are in any order at all?
These are not in a, like, you should do this first and then this. This is just a list of 7 things you can do. All right, break apart fractions. Well, if you've got, sometimes they give you one that's already added together. It's like, sine plus cosine over secant or something. Well, then you should break it apart and say it's sine over secant plus cosine over secant. Get how you can break those apart? Or, that's the kind if they were adding, or if they were like this, sine x cosine x all over tangent x, you'd have to know that you can break that apart into sine x over tangent x. And here's where I've made a mistake sometimes. Sometimes I think that the other one, the other fraction, would be cosine x, which is right, but then I think it's also over tangent, but it's not. Because if this is a multiply, then what's got to be down there?
1.
A 1, yeah. Okay, that's how you'd break up something that's a single fraction and break it up into 2 if it's a multiply up here. See, these are being multiplied, so this is a multiply. All right. Next, the concept of using conjugates. If they ever have something like this, 1 over 1 plus sine or whatever, then you can multiply by 1 minus sine. That's the conjugate of 1 plus sine. And then bottom line is good things happen. This turns into squareds on the bottom, and then a lot of times that can then be substituted with an identity. So conjugates are powerful. Okay, when can you do that? Anytime, because that is equal to 1, and you can always multiply by 1. In the middle of a proof you can do it. In the middle of a solving you can do it. In the middle of a simplifying you can do it. You can multiply by a conjugate anytime you want. I'm not saying it always solves all your problems, but it's a strategy. Yes? Yes. If it was sine plus 1, would it work the same way? Absolutely. If the problem you got had a sine plus 1 on the bottom, you could then change and multiply that by sine minus 1. I mean, you can multiply by anything you want as long as you do it on the top and the bottom, right? And yes, it would still do the same idea. All right. Moving on. The next one says, look for differences of squares and simple factoring. Difference of squares is huge. Huge. So if you had like sine squared x plus cosine squared x, that's not a difference of squares, is it? What's the difference have in it? Subtract, a minus. All right, so can't do difference of squares there. But what could you replace that with? 1, because you know that's an identity. That's like number 6 here. Look for identities. But if this had been a minus, then that's a difference of squares. And that could factor into sine and sine and cosine and cosine. I'm being sloppy here and leaving off the variable, but it'll save me a lot of time. And a plus and a minus. There we go. That's factored. Okay? You need to get that idea. If these were 4s here, could you still do difference of squares?
Yes.
Yes, you could. Then it'd just be sine squared and cosine squared, sine squared and cosine squared. All right. Next one. Change everything to sine and cosine. That is a powerful strategy. It sometimes gets messy, but it very often works. So if anything like tangent can be changed into sines and cosine, sine over cosine. You can change everything to sines and cosines. Anything that's written can be changed to sines and cosines. All right? So that sometimes is a really good idea. Number 6, look for identities. Yeah, you just got to know those identities. If you haven't spent some time studying them yet, where you actually just look at that sheet we gave you or the flashcards I made you, you need to. That'll help a lot. And next up, number 7. If it's a proof, look to see where you're going. Like if they say the thing equals tangent, well, you know you better try to figure out how to make the thing into tangent. Or make the thing into sines and cosines so that, you know, the sine over cosine would be tangent. So it gives you a big clue on a proof by telling you the answer, and don't just ignore it then. So if we ask you to simplify, it's harder because you don't tell you what the answer is. When we ask you to prove like this, they've told you the answer is sine. So you can take a lot of clues from that. Oh, it's only one thing. I need to put this and this together. I'm going to need a common denominator to add them together. Because I know they have to be added because it comes out to one thing. So use the fact they told you what the answer is. A lot of kids just sit there and try to simplify this blindly, not even thinking about where it's supposed to go. All right, let's go back to this now. That should be an easy one. Give it a shot. About 30 seconds from now, I'll come back and we'll see if you get the right answer. This one should have been a no-brainer. If you knew this part, woo! If you knew this part right here is negative sine of theta. Please stop talking. It was okay until now, and now it's not. This part right here would be negative sine theta. Then the top and the bottom can now cancel, and leaving the negative behind, and they replace with 1s when they cancel, so it's -1. Raise your hand if you had that one right. Okay, good. Let's try this one. Try to go rapidly, please, because these are easy. They need to come quickly. Scratch paper. I got 8 problems for you to do. This is not going to work to squeeze it in the sides of the worksheet. Please, just get some scratch paper. All right, so this and this cancel, make a 1. 1 and the -1 cancel. It's gone. It's just sine over tangent. Can I leave it that way? No. Because tangent is sine over cosine. So it's sine over cosine. And technically I need thetas and all this. I'm skipping that part to save time. The flip and multiply turns into sine cosine. Sine over 1 times flip and multiply cosine over sine. And then that means these cancel, and the answer is cosine. Raise your hand if you had that one right. Okay, good. Moving on. Find all the solutions. Now, don't make the mistake I did on this one and think that you can divide by cosine on both sides. I had forgotten that you're not allowed to divide by x on both sides of an equation. It's not allowed. Like if you had x plus 4 equals 7, you are not allowed to divide by x everywhere. It's illegal. It will give you a lost, oftentimes cause a lost solution. So anyway, you have never, if you didn't notice this, you have never been able to divide by x ever. If you had like a 2x equals 7, you'd divide by 2 on both sides. You couldn't divide by x on both sides. All right, so bottom line is you cannot divide by cosine on both sides. It'd be cool if you could, but you can't. So you shouldn't. So you don't. And then you have to do this. Minus cosine theta equals 0. And why is it good to set something equal to 0 if you can? Because then, if you could factor it, which you can, then you can just set each of these parts equal to 0. That part has to equal 0, and that part has to equal 0. Remember this? See if you can factor it and finish it from there. Okay, so I have factored out the cosine, and that leaves me with sine squared, or sorry, sine minus 1. And now I have two parts. This part has to equal 0, which would be cosine theta equals 0. And then this part has to equal 0. Sine theta minus 1 has to equal 0. One step at a time. This one, cosine 0. Where is cosine 0? It's wherever x is 0. Because remember, cosine is x. So if you're thinking, okay, I want to draw a triangle, you can't draw a triangle because you don't have two sides. You have a 0. You can't have a side of 0, so it can't be a triangle. So it's either got to be here, or here, or here, or here. And I happen to know those. That's at 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Now, cosine is x. If I was making my little list of things to study tonight, I gave you 7 things already. I might want to remind myself that sine is which one? Y. And cosine is which one? X. So I want x to be 0 here. X is 0 right there, and x is 0 right there. Can they both be answers? Yes, they can. Because there's two different things that would give you an answer of 0. This one, which is pi over 2. Cosine of pi over 2 gives you 0. And the other one, which is down here. If this is 1 pi over 2, this would be 2 pi over 2. This would be 3 pi over 2. So pi over 2 and 3 pi over 2 are the two answers for this side of the problem. Do you get that? Okay. Because they're both spots where cosine, or the x part, is equal to 0. Now, some of you are thinking, well, how come there's two answers sometimes and sometimes there's only one? Well, basically, if there was limitations on this, like you couldn't have cosine be anywhere outside here. Do you remember that little deal for inverses? Cosine could only be from here to here. This isn't an inverse, though, so we don't have that restriction. So we can have it wherever it falls. There's two spots. Okay, next is sine minus 1 equals 0, so sine theta has to equal 1. So where is that true? Sine is the y. Where is y equal to 1? Y is equal to 1 right here. And is there any other place where y is equal to 1? Nope. And so that's the only place, which is pi over 2. And since I already have pi over 2, no need to mention it twice. There are my final two answers. Raise your hand if you had, oh, wait. You were going to say plus 2 pi n, and you would have gotten it wrong because all solutions from 0 to 2 pi. And if you say plus 2 pi n, you're saying it can go on forever. And you don't want to say that because this specifically says we only want the answers from 0 to 2 pi. But otherwise, that's a good point. If they hadn't said any limit on this, if they hadn't said that, if they just said find all the solutions, then you'd want to say these angles plus 2 pi and 2 pi just once? No, we could do 2 pi any number of times. Okay, so was Mrs. Retta Penning using 2 pi n or 2 pi r, or what was she using? 2 pi n? All right, good. Or n can be any integer. In other words, you can add 2 pi or 4 pi or 6 pi or 8 pi or 10 pi or 12 pi or anything like that. All right, moving on. Here's a proof. See if you can handle this one. There's a famous movie called A Few Good Men, in which Tom Cruise is badgering this witness, and he says, "You can't handle the truth." We'll see if you can handle the proof.
Wow.
That was a long way to go for that one.
Are we allowed to swear in court?
No. All right, I'm hoping you're knowing that you should look at your answer and see where you're going. Do you get that where you're going, you only have one thing? How can two things become one other than getting married? We can find a common denominator and add them together. All right, so I'm going to make this have a 1 on the denominator, and then to make that have a common denominator, I can multiply by tangent on top and bottom. That would work. Option B. I go with changing cosecant to 1 over sine x minus cosine x over tangent x. And then I can notice that that one can simplify down because tangent is really sine over cosine, so I can do a little dance there. That's option B. How many want the one that I already started here? Is that what you guys did? No. Okay, that's most would. Okay. Who did the option A where you put it over 1? Only one person. So we're not doing that way. Okay. Sorry. This one is cosine over sine over cosine. I'm just simplifying the circled part there. And then that's going to simplify to cosine times cosine is cosine squared over sine. And what I had originally is still drop this down. 1 over sine x minus cosine squared over sine x. Ooh, I see why this is good, because now they have a common denominator, and I can make it 1 minus cosine squared, which I recognize as being important, over sine. And again, these should really have x's, x here, and an x here, I'll put an x here, and an x there. And then, what's 1 minus cosine? All right, sine squared x over sine x, and that's just sine times sine on the top. So I can cancel off one of these with one of these signs, and that leaves me with just sine. And is that what I wanted? Yes, it is. Notice how I have to finish. Sine x equals sine x. Then it's a proof. Otherwise, it was a simplify problem. If it's a proof, you have to end that way. Say this equals this. That's a proof. All right, question? Your answer needs the x's in them. During your work, for the purposes of the video, I'm going to say you need to have your x's in there. If I'm grading your test and you had forgotten that part and you had gotten to the end and remembered to put them back in, which would be like a little miracle, then it would be okay. I would have allowed that. But technically it's not supposed to happen. But I would hate to have something that's really complicated like this and you figure it out and you only lose because you forgot to write some x's. I don't think I'd do that to you. All right. All right, move on. Simplify. Simplify. All right, here's what you should have been thinking here. First of all, we haven't used conjugates very much. That'd be kind of fun. I could multiply by what on the top and the bottom? 1 minus cosine theta. Now, you don't have to do that. There's other ways. But I just want to remind you that's an option. That'll kind of fix things a little bit. Do you get how the bottom will come out to 1 minus cosine squared? And that kind of sounds like one of those identities. All right, so that's an option. Did anybody do it a different way? All right, what'd you do? All right, that'll work too. So I'm going to go with option B. 1 minus cosine squared theta over, now if you'd have suggested that, I would have never done it. 1 plus cosine theta. I could tell what you were thinking, so I decided to just say it. All right. So this one I could change now. It seems like this could just cancel. Okay? But can they? Now you got to factor it. I'm glad you knew that. Factoring. Notice it's a difference of squares. Notice it's squared. Notice this one is squared. That's the one people don't usually notice. 1 squared is actually a perfect square. In other words, 1 squared is 1. So that's like a thing that's squared. That's a difference of squares. If you hadn't noticed it already, now you hopefully do. It's 1 plus cosine times theta. 1 minus cosine theta. And then it's all over 1 plus cosine theta. And then I can go cancel, cancel, and then my answer is 1 minus cosine theta.
It's way easier too. So sick.
This one wasn't that bad either. I agree that the conjugate would have worked fine too. But I thought of the conjugate, and since somebody else had thought of the other one, I thought I'd go with that. All right, moving on. Simplify. Except it's a little more complicated. Not super, but... So here we go. This one on top, I'm going to say 3. I happen to know the answer, so I'm just going to jump to it. You would probably have to fight through it for a while to figure out what it factors to, but it's 3 sine x and a sine x, and there's got to be, to make it a -1, it's got to be a +1 and a -1, and I happen to know it's going to be a +1 here and a -1 there. I would definitely want to check it though. First, 3 sine x squared, yes. Outside, +3, no, -3, and then a +1 makes it -2 sine x. This is the key. If it doesn't make that, you can't do it. And the last is this one, and I've made the little Stewie face. Anyway, and then I have on the bottom 3 sine x plus 1. Cancels, sine x minus 1. Raise your hand if you had that one right. Good. All right. You noticing we're doing a fair amount of factoring? You notice the quadratics are coming up a lot? You notice that we've done some conjugates? All right. Oh, wait a minute. You want to take sine x minus 1 and make it simpler? Tell me how. Okay, if it had been squared, then we could maybe do something with that. But all right. And now, solving. This is not the... It's the hardest solving one we're going to do. But it's not the hardest one of my practice ones. The hardest one we save for last. We'll see who can rise to the occasion.
Can you do it in all?
Since this one's separated already, I'm going to take this part and set it equal to 0. Sine x plus 1 equals 0. Sine x equals -1. Where is the y -1? The y is -1 on this one. And so therefore it's this one, which is what degrees? 270 or 2 pi. In degrees it'd be 270, or in radians it would be 3 pi over 2. Raise your hand if you had that one. Good. Then, yes?
What should we do on problems where we get an impossible answer?
Good question. Like on one of your homework questions, it comes out and asks you, like, I want sine x minus 3 to equal 0, like this. What do you do when it says something like that? Well, it's impossible, because you can't have sine equal 3. Think about it. What's the biggest sine can ever be? 1. And so if you're asking you for sine to be 3, that's impossible, and you say there are no solutions for that part. Absolutely. It was on the homework yesterday. All right. So if you're asked to give something that's not possible, then you say it's not possible. All right. So let's move back to this where it was possible. This one comes out to be 2 cosine x minus 1 equals 0. 2 cosine x equals 1. Cosine x equals 1/2. Please don't talk while I'm talking. It's a bit distracting. Okay. And then, what angle would that be? That's actually 2 angles. Because where is cosine? Where is cosine positive? All students take calc. It's here and here. So I need a triangle here and a triangle here. This triangle, with cosine being adjacent over hypotenuse, 1, 2, and square root of 3, is that a 30 or a 60? It's a 60. So it's 60 degrees, and the other one would be 360 minus 60, which would be 300 degrees. If you did that in radians, you would have said 60, which is pi over 3, and then 5 times that, which would be 5 pi over 3. Raise your hand if you had that one right. All right, good.
Oh, wait.
Questions? Yes? Why can't you put a negative? We never have answered with negatives. We've only answered between like 0 and 2 pi, which is never negative, right?
But when it says all,
If it says all solutions, then you don't want to list all the negative ones and all the positive ones. You still just list all the positive ones. So just don't think about negative solutions. Just do, most of them have limits. They'll say between 0 and 2 pi, or they'll say between 0 and 360, and that implies not negative. All right, and here is the Mac Daddy, the big kahuna, the spawn of Satan, perhaps. Why would you want to find that? Good point. Well, this is just the hardest problem. How about that? Why don't we just, instead of labeling it something like really scary, it's a challenging one, but it is, I don't want to imply it's impossible. It's possible. Things like this are on the test, which is why I'm practicing things like this. Okay, it's doable. It is doable. Somebody in this room is going to figure it out. In fact, I'm getting bet on 7. See if you're one of the 7. All right, so here's an idea on this last one. Conjugates. See that 1 plus cosecant? It's very possible you could use conjugates. How many of you actually felt like you were successful and used conjugates? Ah, lots of people. So let's try that. All right, so I'm going to move this stuff over a little bit here. I'm going to go 1 minus cosecant x, 1 minus cosecant x, and when I do that, the point of doing that is the bottom becomes nice. It becomes 1 squared, which is 1. Outside and inside are opposites of each other, so they cancel. And the last becomes minus cosecant squared. That's the bottom now. Now what's the top? The top, I would not multiply the top together. I would leave them separate. Let me show you what I mean. I'm going to leave this cotangent alone here, and it's still poised and ready to be multiplied, but I wouldn't multiply it because it's probably going to end up canceling later. I've seen that many, many times where kids have multiplied it in, and then they just have to factor it back out again. Okay, so I would not do this multiplication. I would leave it and see if that cotangent just cancels off. Besides, think about it. Don't we need one of those in our answer? So all the more reason to not muck it up by multiplying this cotangent into it. All right, so now, the 1 minus cosecant squared. Here's where it's a major leap, and who noticed what I'm talking about? You know what I'm talking about? What am I talking about? So down there, you want to put in what? Negative cotangent. Why not regular cotangent? Because go back to what the saying is. The one with the coat is cozy. And if I move the 1 to the other side, it would look like this. Do you get what I'm saying? Do you get how the saying gives me cosecant squared minus 1, and I have 1 minus cosecant? See, it's exactly opposite. So therefore, I don't put in cotangent, I put in negative cotangent right there. That was probably the biggest leap. So I'm going to rewrite it now in green. The top has stayed the same. Cotangent x, 1 minus cosecant x, all over cotangent squared x. And again, this right here came from knowing that this right here was backwards of one of those identities that we know. Okay, and now you have to notice that this cotangent can cancel one of my cotangents on the bottom. Okay, I'd be okay with this kind of work. You scribble out the squared and you cross off one of these. I know what that means. But in case you don't know what the heck I'm doing, I'm going to write this out. This cotangent squared could be cotangent x times another cotangent x. That's how you get cotangent x squared, right? And then one cotangent can cancel the other cotangent. Don't forget this negative down here. Now it's 1 minus cosecant x over negative cotangent, and I'm really close. That negative cotangent, if I look back at the original, needs to turn into a negative tangent. So all I have to do, I replace cotangent right here with, instead of cotangent, I put 1 over tangent. And then that can flip and multiply and be back up on top. And I'll have I'll show you that step. That comes over here and becomes negative tangent over 1. And then when I multiply it out, I'm going to put the negative tangent in the front so it looks like the other one does. And then 1 minus cosecant all over 1. And how do I finish a proof?
It has to equal it.
It has to equal, and then I write the other thing from up here, and I bring it all the way down. Negative tangent of theta probably, or is it x? No, it's just, oh, this is supposed to have an x in it, sorry. I'm sure that didn't mess anybody up, but, and then 1 minus cosecant. Notice I've got that nice, shh. Notice I've got that statement at the bottom. This equals this, you gotta end with that. All right. Now, at this point, you've been doing this for like 2.5 weeks, okay? And you started out not having any clue what was going on, I could tell. And now I think some of you have a clue what's going on and are going to be fine tomorrow. What I recommend is that you take your homework that you have in front of you right now and check the answers, which are being posted like right now or within the next hour. They will be posted. Check them. If you have something that you don't understand, realize there's always a chance the key could be wrong, so don't just completely freak out. But you maybe want to check with a friend on anything you're not matching up with the key on. I'll be here in the morning too. If you want to come and get some extra help, I'll be in the morning. So.